lab paper, okay? You look at your lab paper. The assess procedure. Most of you said either two things. If you said find the mass, write your name, find the mass, subtract, find the mole. I looked at your data set. Did you have a mass, a difference, and a mole? So that's how many things you told me you needed in a procedure. 4 things. So your data table had to have 4 measurements in it, because that's what you told me in your procedure you were going to have. You're going to have a mass, a difference, and a mole. So if you didn't have those 4 things, I put points on. Okay? Same thing in the calculation section. You told me you were going to subtract and convert. So I looked at the procedure section for the subtraction and the conversion. Now, the only thing that a lot of people forgot was the difference and then the subtraction of the calculation section. Also, when you added up 100 grams, you forgot the unit. It's not grams, it's grams per mole, or you can put U or AMU for a unit. Now, the second way people did it is they told me to go ahead and find the grams, convert it to moles, round that and right, find grams, convert it to moles, and then subtract the moles. Okay? So I was looking for grams, moles, and the difference. So I had how many numbers in my data set? 5. Now, Allie, I know the one who did this, she showed me the difference between the grams. Now, I need the difference between the grams. No, because she told me she was going to find the difference in moles. I don't think that's the cost of that. Okay? But you didn't need that in your data set. Okay? So in your calculation section, I was looking for the 2 conversions to moles first, and then I was looking for the subtraction. Okay? What? Remember, first period, fourth period, first period, you were taking a test. Yeah, okay. Mine is up with that. Now, the only other thing that a lot of people struggle with is calculation or with the observations. I left out, and a couple people put numbers. Observations never have numbers. You just told me a color, texture, the smell. So you told me it rubbed off on your hand, it left a big, it rubbed off and it got gooey after it got wet from the sidewalk. A lot of you told me it got really short after riding on the sidewalk. Really kidding. Some of you told me it had Crayola engraved on the side. That's all fine. But don't tell me it's 2 inches long or has a mass or something. That kind of stuff is dead. Don't put that in the alphabet. Okay? Any questions about anything else? As long as you answered the questions in your complete sentences or with a touch question, nobody lost points to the bottom. Of course, it did crack me up though. When somebody at the TV lab, and I don't remember, there was 1 or 2 people who gave it ratings of like 7 on the scale. It's pretty easy to give it 7. I didn't get that, but whatever. What? I don't know. Let me see it. So, if you said find the difference, you got to find the difference there in the calculation somewhere. There it is. But there's all 5 books if you go in the trash. So you got to show it in calculation. Oh, you show it. Okay? Anybody else? Over. All right, so for CS, how many dots should we have? How many? Okay, 1. Okay, so 1 dot on CS. All right, and how many on O? Okay, so CS is going to do what? Okay, so how do I show it lost 1? And O is going to do what? 1, 2, 3, 4, 5, 6, 7. So it's got 7. Is it happy? No. So what are you going to do to help it get happy? I did not teach him. Don't think so. I'm pretty sure. Oh. That's my boy. Oh. Anytime. All right. So CS lost one, O gained it. Is O happy? So what are we going to do to it? Add another CS. Okay? So if we add another CS, it will give one to O. And then, how many CSs do we have total? So we put a 2 there. Everybody go with that? Marvelous. Oh, I forgot my negative 2 and O. Thank you. I just thought I had already done it. Thank you. All right, so AL has how many? Okay. And F has how many? Okay. AL will do what? AL will lose 3. And F can only take how many of those? It only takes 1. So I have how many homeless electrons here? 2, right? So I'm going to add an F. And that F can only take how many? 1. So now I'm down to only 1 homeless electron. So I'm going to add another what? Another F. And then once I've done all that, all I have left is to do what? Balance it by putting the 3 where? Very good. Everybody go with that? All right. What's the major difference between an ionic and metallic bond? Yep. And ionic electrons are, they don't move. They're locked into place. All right. So how does this affect their properties? What kind of differences will we see that if metals can move and ionic compounds cannot move their electrons? All right. Metallic conducts electricity and ionic doesn't. What else? Ionic's not technically weak, okay? Ionic is really strong too, it's just not quite as strong as a metal. So I'm not crazy about saying that ionic is weak. Covalent is weak. Alright, ionic is, okay, ionic is not malleable. Who's malleable? Metallic is malleable. Okay? That's right. Metals can be beat on and hammered into sheets. Metals are malleable and ductile. What's the word we can use for ionic? They're brittle. Yeah. Okay, questions about that? Can we talk homework? We do this in the right order since I completely botched it the first period, forgot the homework and had to go back. All right, chemistry, bonding. Book. Thank you. All right, that's for when we get to the ones that I had to draw. All right, so if we look at the answers. All right, question 1. A says, ionic or covalent? What did you pick for A? Or number 1, rather? Covalent. Good. Electrons transferred? Ionic. Triple bond? All right. Molecules? Positive and negative ions. Good. Remember, the name ionic bonding comes from the word what? Ions. Ions mean ionic bonding. Metal and non-metal means ionic. Non-metal, non-metal is covalent. Within a polyatomic ion means covalent. Something like, just flip over a couple pages here. Like PO4 -3 is a polyatomic ion. SO4 -2 is a polyatomic ion. What kind of elements are involved in a polyatomic ion? Metals and a non-metal or all non-metals? Non-metals. That's why it's covalent. All right. Trigonal, planar shape. Trigonal is just a different way to say triangular. Depends on the author of the book as to which one they use. So that would be what? Covalent. And resonance. Resonance is what? When a Lewis structure looks, they have different forms, so it's covalent. All right, so number 1 under ionic radius. So F minus and F would be, the smallest one would be F. The F minus means it gains an electron, so it's bigger. Ba plus 2 or Ba, who's the smallest? Plus 2. O negative 2 or S minus 2? As you go down, they get bigger. Who's smaller? O is smaller. K plus or Na plus, who's smaller? Na. And 5 and 6, I told you to mark out because they're isoelectronic. All right, C, you have an atom of sulfur, and sulfur has, this is what I have on board. All right, so this is the first row. It doesn't mean the rows are not sideways, but not too bright some days. All right, so if we look at this first, dot diagram of sulfur has how many dots on it? 6. Your dot diagram should have 6 dots. If you're wondering why 2 are split, you have 3s2, 3p4. P4 has 3 lines above it. 1, 2, 3, 4. So the 3s2 is paired. Those 2 are paired. This one and this one is a single dot. All right, now, N drove first period insane today. So nitrogen is in what group on the periodic table? 15. So group 15 has how many dots? It has 5. But the question said an ion. An ion is something with a charge, right? So something with a charge means it's an oxidation number. So what oxidation number does N have? I'm going to ask oxidation numbers on the test Monday. You might want to know those. -3. Okay, so what does -3 mean? Gain 3. So I drew the 5, and then I gained 3 more. Now, if you listen to Andy a minute ago, he said it would have how many? It would have 8. So you could just draw your 8 in if you wanted to. I was just drawing different colors to explain where the dots came from. So nitrogen has 5, but it gains 3 more in order to get the magic number of what? 8. All right, the next one was the plain old dot diagram again. Sodium has how many dots? 1, because it's in group 1. And then zinc has an oxidation number of +2, which means it does what with its electrons? It loses them. So I didn't draw the dots, and I wrote +2. Okay? Now, the remaining 4 that are on this board are the second row. The second row we said were ionic structures. So here are the 4 ionic structures that go with the second row. Okay, and I'll give you a moment to look at those to see if you're okay with those. But they're the ionic structures that go with that. Maybe the first 3. Can I what? If you want to do it like I did it, some books will show up with just 3 Ks on the other side. I don't typically like it that way though, so. Gotcha. It should be done the way I have it on the board. All right. And just so you know, these are all worth the same number of points as all the questions on the test Monday, because with 80 questions on the test, they're worth like 1.2 each. Yes, I'm not going to grade in decimal points. of 1.2 to give you partial credit. Or what? Well, if you don't want him to die, you might want to get him out of here. Alright. So, if you look at the remaining 4 on the chart. Okay. The remaining 4 that are there, alright, look like that. Sorry about the door. Now you got to pull the door closed. It will not close on its own, or we'll have burglars in here this weekend. All right, look like that. Questions about any of those? What's not stink bugs? I even say bugs, but bugs tend to get pushed on the floor. All right, you okay on those? So the bottom, part D. Number 1 would be what geometry? And 2, and 3, and 4, and 5, and 6. Very good. And on the back end, part E, bond type for number 1, and 2. Okay. Non-polar covalent. Everybody got that? Okay, 3. And 4. Okay, I can't wait to hear this one. 5. Or, yes, because it falls on 1.7, so I would take either answer there. Either answer would be fine. Yes. Number what? Because it's Cl2 and there are 2 chlorines side by side, you would subtract 3.0 minus 3.0, which gives you 0. It'd be non-polar covalent. Okay? And the last one is, yes. All right. The last 5, all right, you have to draw the Lewis structure to determine if they're polar or non-polar. So rather than y'all shouting each other's eardrums out, all right, those are the 5, all right, Lewis structures, and whether they're polar or non-polar. Questions about any of those? I want to hear yes say for the exception. All right, so when you look up the electronegativity for P, P has an electronegativity of 2.1, H is 2.1. When you subtract, you get 0. Okay? Now, because you get 0 on that one, it's nonpolar. In order for it to be polar, there has to actually be an electronegativity difference. Okay? It has to have a dipole, exactly. And there is no dipole there. Yes. Okay? Now, I'm pretty sure I did not put any weird exceptions on the test. Okay? I'm pretty sure I was pretty kind, and I didn't put anything strange on the test. Huh? I am so sorry. Tuesday, we're doing the gas laws. Those of you who want math again, we're doing math Tuesday. Okay? Going back for a while. Don't get excited. It's only going to be about a week and a half. All right. Let us finish up the new stuff so that we can let you review the rest of the period and ask questions. Okay? Alright, the last thing we have to do for the test is to talk about bullet points. And who has the highest and who has the lowest? Alright, that's the part we did yesterday. Now we got to add in van der Waals force. So, to review just briefly. Now, if you have single element only. Somebody brought this up first period. Okay? So it's worth reviewing because it is on the test because it goes to the periodic table and we did it when we talked about the periodic table. You have single elements only. The D block, it has a higher melting or boiling point than who? See? And that's higher than who? Group who? G2, group 2, and then finally group 1. So when we were doing this, when we studied the periodic table, if we had something like, let's just say we had aluminum, we had sodium, we had copper, we had magnesium, and I said who had the highest boiling point, you guys would have said when we did this, who had the highest boiling point back then. Okay? And you said CU, because you would have said C block, group 1, D, group 2, and you would have selected copper. Okay? That's what we did, I guess it'd be last week. Okay? Now, yesterday, before we left, we talked about bonds and who was the strongest and who was the weakest. So who was the strongest bond that we talked about yesterday? Metallic. Okay? So, talked about compounds and bonding yesterday. So, yesterday we said metallic was stronger than who? Which is stronger than who? All right. So, if we look at that, and then we talk about a question like we had yesterday. So, for those of you who watched the video who weren't here, like Tina, all right, and you have something like, I'll say this time we keep doing high. This is lowest boiling point per change. Okay, say I pick lowest boiling point, and I give you options of right? I give you those choices. All right. How do we decide who has the lowest boiling point? The one that's what? The one that's covalent. So now you need to decide which one is covalent. Okay? So, and now you said the one that's covalent. So how do we decide who is covalent out of that grouping? A non-metal and non-metal. Okay? So what do we know about Ni? What kind of bond is it? It's a metallic. All right, CH4 is covalent. And Ki is, all right, and Mn is a metallic. Don't call it a metalloid, not a metalloid. Where are the metalloids at before y'all make that mistake tomorrow on the test, or Monday on the test? It's on the staircase. Okay, so the one that's covalent is CH4. So it would have the lowest boiling point. Okay, everybody with me so far? All right, we have to add in one piece to what we're doing. Okay, one piece. All right, we all there? Do I have to wait on you to write? What? How much of it? Watch it sometimes. Danielle says it's kind of funny to watch it sometimes. says I swear a lot. The subtitle changes by word, swear word. Got it now? Yeah. Are you kidding? Yeah. All right. So the last thing we need to add in are van der Waals forces. Now, those of you who may take a college chemistry class someday, I will warn you ahead of time, I am really oversimplifying this topic. I'm oversimplifying it a lot. However, for the purposes of what we need for our class, what I'm doing will work just fine. Okay? But if you have to take a college chemistry class, this is way too simplified. Okay? So, if one day down the road, you actually kept your chemistry notes and you look back at it, you're going to be thinking, what the heck was she talking about? Okay? Now, I want to say something else, but I can't. Get me fired. All right? These are attractive forces between covalent molecules. So, first of all, if they're covalent molecules, we're only talking about sharing. Covalent. Two non-nuts. No ionic, no metallic. Only covalent. Secondly, attractive forces. So I want you to envision sort of like magnets. So they're sticking together, but are they staying stuck together? No, you can easily pull them apart, which is why they're going to be easy to boil. I just need Miss Curry to pass through. Snatch up some phones again, like she did second period or third period here. Yeah. Pass right on through. Hmm. All right, a dipole-dipole force is an attraction between polar molecules. Number two. Hydrogen bonding is an attraction between hydrogen and a lone pair of electrons. Number three, London dispersion forces are attractions between non-polar molecules. I was going along with that from the figured it out. All right, everybody caught up? So, be dipole-dipole. It has to be what kind of molecule? Polar. You got to remember, polar is dipole-dipole. Why is that polar? Okay? All right, dipole-dipole and polar go together. Now, to to be hydrogen bonding. Hydrogen bonding has to have what? A hydrogen and a lone pair. And the last one, London dispersion, has to have non-polar. Now, once we can identify who's who, to figure out the boiling point and who's higher and who's lower, we got to know who's stronger and who's weaker, right? So, which of these three do you think has the strongest bond, or attraction, I should say, it's not a bond. Who has the strongest attraction? That's what I usually get. Number 2. Okay? You would have been right. All right, number 2 is the strongest. So it has the highest boiling point out of the 3. So, who then do you think would be the weakest? Number 3. Number 3 is the weakest, so it has the lowest boiling point. So, if we take what y'all just wrote down, you said that hydrogen bonding is stronger than who? So I'm going to write this because I'm running out of space. Which is stronger than who? Okay. Now, notice I didn't put this in order from low, increasing or decreasing, because in a minute we're going to do something that's increasing or decreasing and drove first period crazy because they told me I put it in the wrong order. Okay? These are just greater than signs. So who is greater than in terms of boiling point? This has a high boiling point, and this has a what? A low boiling point. So if I incorporate this with what we just did, which type of bond had the highest boiling point with what we just did? Now, your van der Waals forces are going here, way down here in Covalent. They don't have any impact up here. So, if I go back, who has the highest boiling point? The type of bond. Metallic has the highest boiling point. Then who? Then iron. Now, when I get to covalent, this time I'm not going to write covalent. Okay? Because now we can subdivide covalent. Covalent can be subdivided into what 3 categories? Hydrogen bonding, and then dipole, and then LDL. Okay? So, if we're, what is that here? Oh, okay. So, if we're trying to figure out the highest and the lowest boiling point, whoever is a metallic bond has the highest boiling point. Whoever has London dispersion has the lowest boiling point. Okay? Those are greater than signs. That's not an increase or decrease kind of thing. Oh, Sleeping Beauty woke up back there. You have a nice nap? You have a nice nap? I'm glad. I wouldn't want to, keep you from being able to turn it up later tonight after you get off work. McDonald's. Oh, go visit him tonight. He'll be up there on Winston Road. Handing out fries and hamburgers. Try to settle business for a way. Make sure you don't get sent home early tonight. All right, everybody got what they need. All right. Okay, write that down, and we're going to talk about how to do it. Sure. All right, got it? All right, so how do we do it? Tell me what we do. If I want to know and rank those in order of increasing boiling point, what's the first thing I need to do on the test on my day? Find the what? Label the what? Exactly what I do. Okay, so what do I know about H2O? Okay, covalent. Okay, what do I know about CCO4? Okay, interesting. All right, M, CR. What is CR? Is the what? The metallic. Y'all stop calling it a metalloid or a metalloid. All right, NaCl is ionic, and SO2 is covalent. All right, so those are our choices. Okay, we're putting these in order from low boiling point to high boiling point, right? Because my question said increasing, right? So I'm going from low to high. So who is going to be down here on this end? Okay? And who's going to be next to it? Everybody with us so far? And so we got 3 others we need to figure out. Because those are my covalents. So the only way I can figure out the other 3 is to know whether they are hydrogen bonding, London dispersion, or dip-dip. Now, the hydrogen bonding should slap you because there's only one that has what in it? Now, just real quick, you're going to need Lewis structure to be able to do the other 3. Now, to illustrate the water so you understand why it's hydrogen bonding. In order to have hydrogen bonding, it has to have dots and it has to have an H. Just because it has an H doesn't make it hydrogen bonding. Okay? This particular one, we know has to be hydrogen bonding because it's the only one that has the what? The H. But if you had 2 compounds that had H, could you automatically assume one had hydrogen bonding? No, because you got to look for the lone pair. Okay? So we know the water is going to be our hydrogen bonding that's next. Okay? So our problem is the 2 that go right here. Okay? We know that dipole and LDF will be the weakest, right? So who is LDF? LDF is the one that's what? And then dip is the one that is forward. So we need to be able to figure out which one is polar and which one is non-polar, right? So CCl4 and then SO2. So CCl4, and based on y'all's quizzes yesterday, everybody can draw a Lewis structure, so I'm just going to slap them up here on the board. Looks like that. And SO2, I get my dots to show up. Looks like that. All right, what can you tell me about CCl4? Polar or non-polar? I hear polar and I hear non-polar. Which one is it? It's third non-polar. Okay, because Andy changed his mind. All right, what about SO2? Okay. So the polar has what? Is it dip or LDL? Okay. And what about non-polar? Okay. So given that, which one is going to be the absolute weakest in terms of boiling point? CCl4 will be the weakest, and that means who will go here? Yeah. Question. Think you can try one? Okay. I'm going to give you the same question. I'm not even going to change the question. This is the question. I'm just going to change the 5 compounds. Okay. Same question. Everybody got it? CH4. Those 5. Yes, I did. Because it's going to be first. No, this one is going to be first. This is not whole. This one is if it's actually alcohol, not that. It's little bit. Okay. Are we done now? Where we at? All right, so what did you tell me about CH4? Yeah, what did you tell me? Just tell me bond type first. Covalent and KBr and CI and NH3 and PCl3. All right, so from there, we knew we had to draw the structures for CH4. So you got CH4, and you knew NH3. And you got PCl3. Back up to the top. Oh, my. What's in there? All right, so what can you tell me about CH4? Polar, nonpolar, what? Nonpolar, so what kind of forces? One dispersion, dipole, hydrogen bonding. LDL, okay? So what can you tell me about NH3? Okay, it's got a lone pair and it's got 8, so it's got hydrogen bonding. I can work with that. It's also polar, so it would have dip if that's important. All right, and PCl3 is what? All right, it's polar. It's got lone pairs right there. So it's polar, so it has what? Dip. All right, so at this point, we have everything we need to put them in order, right? Okay, so who has the lowest boiling point out there? CH4 is the lowest. Who is the next lowest? Dip, the PCl3. And then the last covalent is who? All right, after covalent comes who? The ionic one, so KBr. And then who has the highest? The metallic, the Ti. Question. Feel okay about it? All right. I gave you review sheets to go with the periodic table. I uploaded those answer keys, and they're on the website for Thursday night's homework. Okay? The two that go with tonight or this weekend are the bonding review sheets. And I'm going to give you the remaining half hour to work on review and study. Okay? Those are here for those of you who are not going on the field trip and maybe pick one up. All right, if you want me to unlock the computer cabinet so you can get the computer, check answers, or check answers as you go, the answer keys to these two are uploaded under today's homework assignment. Okay? Say what? But it's supposed to be rescheduled though, right? Once they get the tour guide thing worked out? Oh, I thought they told me that it was going to be rescheduled. Okay. I thought that's what Isabel or somebody said. No, Tatiana, the first period who was in here, they led me to believe it was going to be rescheduled. Yeah. The first period group that was in here when Miss Burton talked to them, then they canceled it at the end of the day, sort of led me to believe they were going to reschedule once the person who's the tour guide who couldn't do it was going to reschedule their trial. So anyway, if you want me to unlock the cabinet so you can check your answers, if you're working on the multiple choice or the other, I'll be glad to. You have a total of 4 review sheets to be working on. If we're not going to work, I'm going to talk about kinetic molecular sheets. Okay? But we're not going to spread our lanyards or do nothing for the remainder of class. You're a lost cause. I have no issues with repeating my class to take physical science. You choose. You know what you have. The other two you need to get from here unless you can pick one up. Which one is this one? All right, you got multiple choice, farming, and then the little those are the ones that go with the bonding. The other two you should have from periodic table. What? I have absolutely no idea. I don't keep track of what you do and don't have. Huh? I think it's actually 79.